let us look at this example here. In a standard deck of 52 cards, what is the probability of drawing a black face card? So first of all, I hope you all know what a face card is. A face card is either a jack, a queen, or a king, and they've told us that it needs to be black. So it can either be of, let's say, clubs, or it can be of spades. So that means there can be 6 possibilities, 6 favorable outcomes from which we can draw. So what would our probability of this event occurring would become? What are our total number of outcomes? Again, I'm drawing from a pack of 52 cards. So of course, my total number of outcomes are 52. And out of this, what is the probability of drawing a black face card? So 1, 2, 3, 4, 5, 6. 6 becomes my total number of favorable outcomes. And from here, this is my probability. So my probability of drawing a black face card is, if I try to divide this, this becomes 2, this becomes 26. So probability is 3 by 26. A very simple question. Let's look at a more difficult and a version of question which are asked in JEE Mains. If the numbers appeared on 2 throws of a fair 6 die are alpha and beta, then the probability that the quadratic equation this is greater than 0 for all x belongs to R. So now there is a concept of quadratic equation that we have to use here. First of all, they've told us that x square plus alpha x plus beta, this is always greater than 0. And we know for any quadratic equation to be greater than 0, the determinant, it has to be less than 0, and the a for any general equation, let's say it's ax square plus bx plus c, a has to be greater than 0. So here we can see that our a is 1, so a is greater than 0. That means we do not have to look for this one. However, for d less than 0, what is our d? B square minus 4ac is less than 0. So b square alpha square minus 4 into beta, this is less than 0, or we can say is alpha square is less than 4 beta. So this is the condition that alpha and beta have to follow for the quadratic equation to be always greater than 0. Now, what are the cases when a 6 faced die is rolled? So first of all, when 2 dice are rolled, what can be the total possible outcomes? Total outcomes would be 6 square, which would be 36. So I mean, we can either get alpha can be 1, 2, 3, 4, 5, 6, and beta can also be the same. So now let us take this case by case. Let us take the first case. What is the first case? Let us assume that beta is equal to 1. If beta is equal to 1, that means we are saying that alpha square has to be less than 4. And what are the values of alpha that we can choose so that it becomes always less than 4? I think we can only choose one value, that is alpha is equals to 1. Because if we choose alpha to be 2, it would become 4, and 4 is not less than 4. You have to keep this thing in mind that there is not an equal to sign here. It is a less than a function here. We cannot take 3, we cannot take 4, 5 or 6. So our case 1, we have just one possibility. For case 2, let's say if I take my beta to be 2. So my alpha square, it has to be less than 8. So what are the values of alpha that would satisfy this equation? It can be 1, it can be 2, it cannot be 3, because 3 square is 9, which becomes greater than 8, so it is not less than 8. So here we have 2 possibilities. Here we had 1 possibility, here we have 2 possibilities. Now let's look at a third case. Case 3. What if my beta is equal to 3? So my alpha square, it has to be less than 12. So what are the values of alpha that will satisfy this equation? It can be either 1, it can be either 2, it can be either 3. So there are 3 values that satisfy this equation. Let us look at our another case 4. Let us look at our another case, which is case 4, where beta is equal to 4. So my alpha square, it has to be less than 16. So what are the values that I can choose? For alpha, again it will be just 1, 2 and 3. I cannot choose 4 because 16 would not be less than 16. So here also we get 3 values. Now let us take case 5. Here if beta is equal to 5, so alpha square would be less than 20. So what are the values of alpha that satisfy this equation? 1, 2, 3 and 4. Of course I cannot take 5 because 5 square is 25. And case 6, the final case where beta is equal to 6. So alpha square, it has to be less than 24. So again, the values of alpha that I can choose are 1, 2, 3 and 4. So from here we have 4 values. From here we have 4 possible outcomes. So what are the total possible outcomes? Sorry, total favorable outcomes. So favorable outcomes. That means all those numbers for which this equation would be satisfied, which is what that the quadratic equation x square plus alpha x plus beta is greater than 0. So from here we have 1, here we have 2, 3, this 3 becomes 6, this 3 becomes 9, this makes it 13 and this makes it 17. So 17 by 36, since 36 was our total probability, sorry, favorable outcomes is 17, our probability becomes 17 by 36. So this is how we get we find out the probability. Now what are these 17 outcomes that we are talking about? When I roll 2 dice, let's say from the first die we get alpha and from the second die we get beta. So what are the values that we can get? It can be either 1, 1, it can be either 1, 2 or 2, 2. It can be either 1, 3 or 2, 3 or 3, 3. So you can simply use these values to find out the combinations that we are getting. So ultimately this is our answer that we are getting. Let's look at another question. Let S be the sample space of all 5-digit numbers. So first let us write this down. What is the first 5-digit number that we know of? It is 10,000. And what is the last 5-digit number that we know of? It is of course 99,999. So total number of elements in our sample space becomes 90,000. So if you are not being able to calculate that from 10,000 to 99,999 there are 90,000 elements, you can simply use AP. We had studied this in sequence and series. Here the final term is given as 99,999. The first term, which is A, that is 10,000, and our common difference is 1. So using that you can find out the value of n. It would come out to be 90,000. Now they've told us if P is the probability that a randomly selected number from S is multiple of 7 but not divisible by 5. Now here you have to understand this concept that the number, let's say if I choose x is divisible by 5. That means I would get a natural number here. But it should not be divisible by 5. That means the thing that I'm telling here is that the probability, it is intersection with 5. That means it should be divisible by 7 but not divisible by 5. That means this can be written as 35. So this, when this also comes out to be natural number, we must say that this should not be included. So to find out our P, we can say, let's say this is my probability P1, this is my probability P2. So I would say that my total probability would become P1 minus P2. So P1 is again, I'm repeating this again, P1 is the probability that the numbers, 5-digit numbers, are divisible by 7. P2 is the probability that the numbers are divisible by 35. So if I remove those numbers, that means I have basically removed the intersection of numbers that are divisible by 7 and not divisible by 5. So let us calculate P1 here. So for P1, so first we have to find out the total numbers that are divisible by 7. So the smallest number, first let us find out the smallest number, which is divisible by 7. What is it going to be? Is it going to be 10,000? No. 10,001? No. 10,002? No. 10,003? Yes. 10,003 is divisible by 7. Similarly, let us find out the largest number that is divisible by 7. The same thing. And this would be equal to 99,995. So how many elements are there in total from 10003 to up till 99995. So let us find that out using AP. For here AP, the nth term that we are talking about is 99995. The first term that we are talking about is 10,003. N, we have to find out that how many, of course, numbers are there, and our D, which is our common difference, that becomes 7. So from here, after calculating what is the n that we are going to receive, it is going to be 12857. So this is our total number of 5-digit numbers that are divisible by 7, 12,857. Now let us do the same thing for 35 as well. For P2, what we can do is the smallest number that is divisible by 35 would be 10010. And what would be the largest number that is divisible by 35? It is 99995. Again, the same one that we had received for 7. So how many items are there, or how many total number of elements are there from 10,010 to 99,995? Let us find that out again using AP. This is 99995. This is equal to A, which is our first term, it is 10,010 plus n minus 1. And what does our D become here? 35. So upon calculating this entire thing, what is the n that we are going to receive? It is going to be 2572. So basically we found out the total number of elements that are divisible by 7, and we found out the total number of elements that are divisible by 35. So we have to remove, so our total number of favorable outcomes become 12,857 minus 2,572. This way what we are doing is that all numbers that were divisible by 7 have been included, and those which are divisible by 7 as well as 5 are getting removed from our subset. So upon subtracting this, what do we get? 10,285. So this is our total number of favorable outcomes. So what does our complete entire probability of this event occurring become? It becomes 10,285 upon 90,000. 90,000 was the total value. And they've told us that this value is equal to P. P is the probability that the randomly selected number is a multiple of 7 but not divisible by 5. Then we have to find out the value of 9P. So what would 9P become? It would be 10,285 upon 10,000. So from here we get our 9P to be 1.0285. Yes, so this becomes our answer. Let's look at a few more examples. Now in this question, an urn contains 9 balls, of which 3 are red, 4 are blue, 2 are green. 3 balls are drawn at random without replacement from the urn. Now without replacement, I hope you all remember, we had studied this in permutations and combinations. So in this question, a few concepts of PNC would be applied. The probability that the 3 balls have different colors. So first let us find out our total possible outcomes. What is my possible outcomes going to be? Possible outcomes is going to be, I'm drawing 3 balls out of 9, so it is going to be 9C3. There are 9 balls, right? I'm drawing 3 out of them, so my possible outcomes can be 9C3. And let us now find out favorable outcomes. For favorable outcomes, what have they told us? That 3 balls are drawn at random. What is the probability that the 3 balls have different colors? And how many colors are there in total? Red, blue and green. So there are 3 colors, and we have to draw 3 balls which are all of different color. That means I have to draw 1 ball from each and every color. So what would my favorable outcomes become? For red it would become 3C1 into, for blue it would become 4C1, and for green it would become 2C1. So what is my ultimately the probability? Probability would become 3C1 into 4C1 into 2C1 upon 9C3. So this is my probability that I'm trying to find out. So let us calculate this. 3 into 4 into 2 upon 9 into 8 into 7 into 3 into 2. So from here 3 cancels 9, 4 and 2 cancels 8. So from here we get our answer to be 2 by 7. So this is how PNC concepts are applied in probability. Let us look at a few more questions. If the letters of the word rabbit fish are randomly arranged, then the probability that there are exactly 4 letters between R and S. Again, we had studied this type of question in permutations and combinations. The only thing here is that now we have to include one more term, which is our total possible outcomes, which is in the denominator. So first, for this type of question, what is our total possible outcomes? How many letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 in total letters in the word rabbit fish. That means our total possible outcomes would become 10 factorial. What would be our favorable outcomes? So first, let's draw 10 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now what can we say is that if my R is here in the first place, that means there have to be exactly 4 letters in between. So 1, 2, 3, 4. So S can be here. What else can be my cases? If my R can be here and my S can be here, what are the other cases? My R can be here and my S can be here. Other cases, my R can be here and S can be here. And the final case is that my R can be here and S can be here. Apart from this, I do not see any other case where R and S would be at a gap of 4 letters. Now, of course, I can interchange S and R as well. So, of course, it is not necessary that R would always be in the first part and S would be in the second. I can interchange those as well. So, how can I write my favorable outcomes from here? So, my favorable outcomes from here would become firstly, there are 5 cases in which R and S can be arranged, and R and S can be interchanged among each other as well. So I multiply this by 2. That means in total 10 cases can be formed. Apart from this, how many letters are left? 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. 8 letters are left. They can be randomly arranged among each other. So it can be written as 8 factorial. So what does my probability turn out to be? It becomes 5 into 2 into 8 factorial upon 10 factorial. So how can I write this? This would become 10 into 8 factorial upon 10 into 9 into 8 factorial. 8 factorial, 8 factorial cancels out. 10 and 10 cancels out. So my probability comes out to be 1 by 9. Now, of course, let's say in the question, if they had asked you to find out the percentage of probability, then you can simply multiply this by 100 and get the probability. Apart from that, generally we consider probability to be from a range of 0 to 1. So that is why we give the fractional answers of probability. So this is how this type of questions are done. Now we will look into some algebraic rules that we had already studied in sets and relations, but for probability, how do they differ and how can we use them?